Okay, so this is video 4 for Justin P. So the first part here is using the simple factory classes and the singletons, which kind of go together for me at least. So the bullet constructor factory here is set up as a singleton class with the pointer instance and the private constructors. It's also got some of these functions here. Actually, okay, I'm sorry. These aren't even actually, or at least this function here isn't even used. These are the public functions here that are used. Here is the private create bullet for creating a new bullet. If the get is fired is true. So this allows it to only be create one bullet at a time. And then this is the recycling of it right here. And then the actual recycle function, the terminate, which includes the delete and null pointer. And then these are the functions that the class actually uses. And this is obviously the destructor. So this is what goes through and deletes everything when the game is exited. So there's that. The spider factory. So these are, once I had the first one, I basically ended up copying and pasting most of them. So they're going to look very similar. The only difference really is the actual functions that are called by the class. So the same thing with the private constructors, the pointer instance, the functions that the class actually calls. And of course the private recycle and create here. And then in the spider factory, the same thing, the private create of the spider. All of these have the pointer instance at null at the top here. The private recycle, and the while loop, which destroys the pool of the spiders. And then in the H for it was the, I'm sorry, this is for the scorpion. Same thing here. Private recycle and create. The instance, the functions. And then in the scorpion factory here, same thing with the if else, with the if it needs to be created or not because it's empty. This one also has got these other things for setting the sound manager to play or stop the sound. The scorpion also has an extra thing just for the random positioning of its Y value. So that's set here in the private create scorpion function. And the while loop for destroying the pool. Flea factory, private constructors, the instance, privates, private recycling create, the factory, if else, if it's empty, wave manager, sound manager, and the destructor. So that's all of those. Let's see real quick. So that was the factory singleton pattern, observer pattern. Like you said, it's used a lot of times. I guess I just pulled up the mushroom to show again. It's calling back to the mushroom grid. The explosion I don't have with the object pool. It would it'd be very easy to do it. I guess it just skipped my mind and I missed out on time to get it in. So that's not there. It's just creating a new whenever the explosion happens. The blaster I should so the blaster as we saw last time in the last video was using the either the AI input or the keyboard input. And these are the get up, get down, get left, get right functions, and then get shoot. And these are never actually called in this class. So I'll go up to the update just to show you. Update here, there is no get up or any of that, or checking keyboard presses, so that's all good. The bullet, I believe I just showed with the factory. I've got enough time, I should show the Centipede here. That these are... So I have a base class for the Centipede. Actually, maybe it's easier if I show it here. So the Centipede Centipede node is the base class for my two other classes, which would be the head and the body. It just basically has some general setups of counters, speeds, offsets, the boundaries. They both have position, sprites, bitmaps. They both have just a check for a key press to switch back and forth between retractor mode and player mode. They both have a spawn mushroom function, a spawn explosion function, draw, and I should show those real fast. These are just the things that I just talked about. Spawning of the mushrooms. They both have a change body to head function, which I went through in my first video. So they both derive and get this function here. This is just for when a segment gets hit, it destroys everything, connects all the pointers, all that fun stuff. So that is what the base class has. I did originally have the collision in the base class because I figured that would be obvious, but there was a section, I believe it was the score setting, for updating the score. You get different scores if you hit the body or the head, and that's different between the two, so I ended up having to put a collision function in both of the two head and body classes. So this is the body class here. So these are pretty general stuff. I think I went through this already, so I won't really go into too much detail, but it's got the body update, which is called by the head. The body update calls the check head or the check body, depending on which one is in front of it. It has a movement function, which is also called by that same function, and a collision with the bullet. Let's see. So I'm not using the state pattern, as you saw with that gigantic section. The head is definitely the only thing that is that has the logic in it, which I'll just show this real quick. This is the only, the head has the check for mush function, which checks for mushrooms and if they're poisoned or not. So none of this stuff here was in the body. So it's the only one, and it only checks once every 16 frames, so once per cell. So that's performant there. Let's see. I should probably cut this video now. The update function for the head uses the counter if it's going up or down. So if it's in a turn, it's not going to be incrementing the counter. Then the counter 2, which is actually used, counts up to 16. The offset divided by the scalar. So the scalar changes based on the speed, and the offset is 16. So at the first level, it's just 1. So it's once every 16 frames, and then it will do the check for mush. Otherwise, it will just use the movement bool to change its position, and then once this hits 16, it will check for a mushroom again, set booleans, which the movement bool uses for movement. So that's about as performant as that can be. And with that, I will go ahead and end this video. Thanks.